ellipse. So let's look at the definition first. The locus of a point which moves such that its distance from a fixed point bears a constant ratio less than unity to its distance from a fixed line is called an ellipse. Okay, and the equation of the ellipse is x square by a square plus y square by b square equal to 1. And here the important thing is a has to be greater than b. This is the simplified version of the bigger equation. Remember, ax square plus bx by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. Right? Based on some conditions within this, you would have an ellipse. But by arriving at this equation, immediately we know what type of conic section it is. Now, let's do the derivation. How did this equation come? So let S be the focus and L be the directrix. SZ be perpendicular to L. So let's say we have a point S and we have a directrix L and a perpendicular from S to Z. Now here important thing to remember is that when you have a directrix and a curve and this is a focus, you will have one line which is a straight line, right? Part of the axis, but starting from the directrix to the focus. Otherwise, most of them would be two lines, one from M to P to S. But in this particular case, it would become a straight line, right? So in case of parabola, this would be equal to this. This would be equal to this. But similar to that, what would it be? Remember, there would be a ratio, right? SP by PM equal to E. Now, in case of parabola, we took the midpoint of SZ. But here, it would not be midpoint because here E is not going to be equal to 1. That is, the ratio is not going to be 1. It is going to be less than 1. So, we divide SZ internally in the ratio of E is to 1 and externally the ratio of E is to 1, right? So, we have to figure out A such that internally it is, so let us say A. So, now it is in the ratio of E is to 1 and externally it is, let's say, A dash, E is to 1 externally. So, SA by AZ, SA by AZ is equal to E and SA dash by A dash Z or A prime Z is equal to E. Remember, this is external division and in this case it is internal division. So this implies that SA is equal to E times AZ and SA prime is equal to E times A prime Z, and we know that E is going to be less than 1, which implies that A and A prime will be on opposite sides of S. So now let's take the origin as the midpoint of A prime. So take this A prime and take the midpoint of this. So this would be the origin. Midpoint would be the origin. Therefore, because it is midpoint, OA dash is equal to OA is equal to A, let's say. Now, let's take an arbitrary point at x comma y. An arbitrary point on the ellipse. Now, SP by PM equal to E, which implies SP is equal to E dot PM. So let's keep this pending for the moment. And let's go back to our previous statements that we had arrived at. So SA is equal to E dot AZ and SA dash is equal to E dot A dash Z. Look at the drawing again. SA can be written as, so let's go back. SA can be written as OA minus OS, right? So SA can be written as OA minus this. So when you minus this, you are left with this. That is nothing but SA. Okay. So let's write it down. OA minus OS is equal to E times. Similarly, AZ can be written as OZ minus OA. Similarly, here this can be written as OA prime plus OS is equal to E times OZ plus OA prime. Now let's do the subtraction of these two. So OA prime plus OS is equal to E times OZ plus OA prime minus OA minus OS is equal to E times OZ minus OA. Now why are we doing subtraction? Because we want the OS. So we have to make the OA dash and OA disappear. And remember, OA is equal to OA prime. These two are equal. See here, they are equal. And if we do the subtraction, this becomes minus, this becomes plus, this becomes minus. And these two get cancelled. So we are left with 2OS is equal to E times OZ plus OA prime minus E times OZ minus OA. Let's open it up. EOZ plus EOA prime minus EOZ plus EOA. These two get cancelled. And remember, OA and this OA prime and OA are equal, right? And they are equal to A. So E times 2A or 2AE, and here you have 2OS. So OS to OS. So 2 gets cancelled. We are left with OS equal to AE. So the coordinates of S is going to be AE comma 0. Okay, so we did the subtraction to get the OS. Now we want OZ. So to get OZ, instead of subtracting, we are going to add those two equations. So OA dash plus OS is equal to E OZ plus OA minus OS, this is dash, is equal to E times OZ minus OA. And we are going to add. So which means OS will disappear now. And these two are equal to A. So to A is equal to EOZ plus OA dash E plus EOZ minus EOA. OA dash and OA is same, is equal, so they get cancelled, and we are left with 2EOZ, 2A. So 2 gets cancelled, so OZ is equal to A by E. So here we got OS, and here we are getting OZ. So the equation of L, that is the directrix, is x equal to A by E, or x minus A by E equal to 0. Now, SP, remember SP is equal to EPM. Now we are going to come back to this. P is the arbitrary point. Now SP is, because we have the coordinates now, we can write it as x minus AE square plus y minus 0 square. PM is equal to the perpendicular distance of Px comma y to the directrix, or from the directrix, okay, to the directrix. So for which the equation we know how to find the perpendicular distance. Remember, the directrix equation is x minus A by E equal to 0. So x minus A by E divided by square root of 1 square plus 0 square, which is equal to x minus A by E. Now let's put these SP and PM in this equation. So square root of x minus AE square plus y square is equal to E times PM. PM is x minus A by E. Now let's get rid of the square root by squaring both the sides. So x minus AE square plus y square is equal to EX minus A the whole square. X square minus 2AEX plus A square E square plus y square is equal to E square X square minus 2AEX plus A square. Okay, 2AEX, 2AEX cancelled. Now let's rearrange this. X square minus E square X square plus y square, and let's take the constants to the other sides. A square E square plus A square. So x square is common, 1 minus E square plus y square is equal to A square is common, 1. This is actually minus. It will become minus when we bring it to this side. So minus 1. So let me write it as 1 minus E square. Now, to get rid of this 1 minus A square, say on the right hand side, if you remember, equation is x square by A square plus y square by B square. We don't want 1 minus E square. So we have to get rid of it. So one way of getting rid of it is, we have to somehow convert this into 1. Which means what? We divide the entire thing by A square 1 minus E square. This square will go inside. So x square 1 minus E square divided by A square 1 minus E square plus y square by A square 1 minus E square is equal to A square 1 minus E square by 1 minus E square. So this and this gets cancelled, we are left with 1. This and this gets cancelled. And we are left with x square by a square plus y square by a square times 1 minus e square is equal to 1. Now, this is also a constant, right? So let us say this is b. Let us say it is equal to b square. So what happens to our equation? X square by a square plus y square by b square equal to 1, which is what we needed. So here important thing is b is again a function of a. Now there are important points, and one point is, since e is less than 1, it is between 0 and 1. See here, e is less than 1. Its square root would also be less than 1. Look at this equation. E is less than 1 means that this is a positive number. 1 minus a number which is less than 1 give you a positive fraction actually. So we can say a square 1 minus e square is between 0 and a square. Remember, this is going to be a fraction between 0 and 1. So naturally, when you multiply a square with a fraction, it will be less than a square. So that means this will be less between 0 and a square. Okay, let's look at this. B square is equal to a square 1 minus e square. A square is equal to b square by 1 minus e square. Now a square is equal to b square times, this can be written as multiplication with a reciprocal of this, right? So reciprocal of a fraction. So which means a square is going to be greater than b square, because this is getting multiplied by the reciprocal of a fraction. So for example, if this is 1 by 4, let's say, the reciprocal would be 4, right? So b square times 4 is equal to a square. So naturally a square will be greater than b square, which means a will be greater than b. So this is the condition for a ellipse. Okay, another important aspect, b square is equal to a square 1 minus e square. Now what will be e? That is what we will look at. So a square minus a square e square. We want e, so let's take the rest to the other sides. Let's bring a square e square to this side and b square to that side. This will be minus b square. Now e square would be a square minus b square by a square. So e would be square root of a square minus b square by a. I have taken the square root of a square in the denominator. So if you are given a and b and you are asked for the eccentricity, this is the formula. So that is one aspect of ellipse. In the next session we will see how to draw the shape of the ellipse. Enough. Bye for now.